Hello everyone. Today we'll be presenting our project on the automatic washing machine simulation using Picsimlab. This project is part of our internship at Amatex, where we applied embedded systems concepts to simulate the functionality of a real-time washing machine. This is about the title slide, and we'll move forward the next slide. Team slide. We are a team of 4 members working on this project. Pranita Reddy, Sri Hari Krishna, Vamsiram, and Rajesh. And the next slide is about overview of this presentation. We'll begin with about the organization section, where we talk a bit about Amatex information technologies and their role in our internship. Then we will move on to an introduction to C programming and embedded systems, as they are fundamentals to our project. Finally, we will walk you through the implementation details and show you the demo working of this washing machine simulation. And we'll move to the next slide. This slide is about Ematex overview. Let's start by discussing Ematex information technologies. Ematex is a pioneering institution that specializes in training professionals in areas like embedded systems, Linux, and IoT. Located in Bangalore, Ematex has been a major role in this field since 2003. During our internship here, we received hands-on training in embedded systems, which was crucial for this project. And we'll move to the next slide. This slide is about introduction to C programming. Now let's talk a little bit about C programming, which is the backbone of our project. C was developed by Dennis Ritchie in 1972 and it's widely used for system programming. C is a procedural programming language and its ability to handle low-level memory access makes it ideal for writing operating systems, compilers, and embedded applications as well. We specifically used embedded C, which is an extension of C, to interact with microcontrollers and hardware components in our simulation. And the key features are the features of C, such as simple keywords, low-level operations, and system-level access, make it a perfect choice for a project like ours. We utilizes these features to control the washing machine simulation, especially when dealing with hardwares like sensors and switches. This is about the slide presentation to introduction to C programming slide, and we'll move to the next slide. Flow of C program. This slide represents the structure of a typical C program and walks you through its various components. Here's a breakdown of what each part represents. The documentation part. The first part of any program is usually documentation. This is where we write comments to describe what the code does. These comments help others understand the program's purpose. And preprocessor statements. Before the program begins, preprocessor statements like hash include studio.h or hash define are used to include libraries or define constants, define constants, but the program will use. These are handled before the main code is compiled. Coming to the global declaration, if you have any global variable that needs to be accessed throughout the program, they are declared here. And coming to the main code, this is where the primary functionality of the program is written. The main function int main is the entry point of the program. Inside the main function, the operation takes place and the subfunctions. After the main function, you can define any other subfunctions that your program needs to be execute specific task. For example, functions to calculate values, print messages, or process input. This is about the slide of flow of C program, and we'll move to the next slide. Learning from embedded C. This slide is breaking down some core concepts you would learn when working with embedded C. And in C, the keywords. In C, certain keywords like int, for, while are used for basic operations. Keywords are reserved words with special meaning. For example, int is used to declare integer variables. For and while loops are used for iteration. And coming to the number systems, embedded C deals with different number systems like various types like decimal, the regular base 10 system, binary, base 2, often used for representing data in digital systems, octal, base 8, less commonly used but still relevant in computing, and hexadecimal, base 16, frequently used in memory addressing. And coming to basic data types, C allows you to declare variables of various basic data types. Some common ones include int, char, float, and double. Int is for integers, char is for characters, float and double for floating point numbers. And the next, modifiers. Data types can be modified with size modifiers like short, long, or long, long to change their memory allocation. And the signedness, a variable can either be signed, can hold both positive and negative values, or unsigned, only holds positive values. And this is about the slide of learning from embedded C, and we'll move to the next slide. Operators and constructs in embedded C. This slide outlines various operations and constructs that they are key to write programs in embedded C. Conditional constructs. This includes the if, else, and switch statements. These help make decisions in a program based on conditions. For example, an if statement checks if a condition is true, and if it is, it executes the block of your code inside. And iteration constructs. Single iteration. The for, while, and do while loops help repeat a block of code. A for loop runs a specific number of times, while a loop continues until a condition is false. Coming to the multi-iteration, for more complex iteration, for and while loops help control repetition. The relational operators. These are used to compare two values. Examples include greater than, less than, or equal to. And the next, bitwise operators. These are used to manipulate data at the bit level. For example, AND performs an AND operation on the bits. And the memory segments. Program in C use different types of memory segments, such as the stack and heap, to store data during program execution. And we'll move to the next slide.
I am Rajesh. Now I'm going to talk about embedded system. An embedded system is a microprocessor or microcontroller based system of hardware and software designed to perform dedicated functions within a large mechanical or electrical systems. There are some categories of embedded systems: standalone embedded system, slave semi-automated independent embedded system, real-time embedded system, network embedded system, mobile embedded system, and hybrid embedded system. The next one is hardware and software components. Let's talk about the hardware components. In hardware components, we can see the microcontroller and SoC and microprocessor. The memory and FPGA are connected to the microcontroller. Then the other one is diagnostic port, human interface, ADC and DAC. And the other requirements is reliability, cost efficiency, low power consumption, efficient usage of power processing power, and efficient usage of memory. The other slide is challenges, and it has lack of inputs and outputs, and using embedded NOS and code optimization and testing and debugging. The next one is development. In development, we use processors, memory, operating systems, programming languages, and development tools. The last one is common design metrics. In metrics, time to prototype, power, performance and correctness, size, maintainability and flexibility, safety, unit cost, and time to market. And the next one is microcontroller. Microcontroller is an integrated circuit which is capable of being programmed to perform a specific task. The design normally has restriction on its embedded system, like memory size, input-output capabilities, peripheral functions, and etc. Things we need to keep in mind to select microcontroller applications, performance, price availability of tools, and capabilities. The next is difference between microprocessor and microcontroller. We can see the microprocessor. There are separate of components, and it has more flexible and more design complexities. There, and we can see the microcontroller. In microcontroller, we can see the all components in a single chip. It has less flexible and less design complexity. Here we can talk about the project of washing machine. A washing machine is a home appliance used to wash laundry. The term is mostly applied to machines that use water as opposed to dry cleaning, which uses alternative cleaning fluids and is performed by specialist business or ultrasonic cleaners. The user adds laundry detergent, which is solid in liquid or power form, to the wash water, and it contains a barrel into which the clothes are placed. This barrel is filled with water and then rotated very quickly to make the water remove dirty from the clothes. Most washing machines are made so that detergent like liquids or powders can be put into the machine. This can help make the clothes cleaner. Washing machine plays a very important role in the modern society. They are used to save human labors, save time and energy. There are different types of washing machines and different operations performed by it. Here we can see microcontroller. In this internship we used PIC16F877A. Bus width is 8 bits. These are 40 pins and there are 33 pins input and output pins, and program memory has 14.3 kilobytes. The CPU speed is 5 million instructions per second and the RAM size 368 bytes. WPROM size is 256 bytes. The series of PIC16 consists of 5 ports such as port A, port B, port C, port D and port G. Port A is an 6-bit port that can be used as input or output port based on the status of Strategic Intelligence Support Activity Register. Port B is an 8-bit port that can be used as both input and output port. Port C is an 8-bit and the input of output operation is used by the status of SIC register.
Hello, I'm Pranita. I'm going to talk about the architecture of microcontroller PIC16F877A. Here we have multiple blocks which are bidirectional and unidirectional. The GPIO pins, EEPROM, RS232, matrix keypad, CLCD. These are the bidirectional. The temperature sensor, ADC, LEDs, buzzers, SSDs, digital keypad. These are the unidirectional inputs and outputs. Let us know about the softwares used in this internship. The Mplab X IDE version 5.50, XC8 compiler and Picsimlab. Let us know about the modes in the washing machine. Here we have different modes. They are daily, heavy, delicates, whites, stains, eco cottons, woolen, bed sheets, rinse plus dry, dry only, wash only, aqua store. And we have different water levels. They are low, medium, max and auto. This is a screenshot from the Picsimlab software where we are having a door button here, a key 4 button here, key 5 button here and key 6 button here. The implementation of the washing machine is when we power on the washing machine or microcontroller, the simulator will displays press key 5 to power on washing machine. As soon as we press the key 5, it will start power on the washing machine, and the CLCD shows all the washing programs like daily, heavy, delicates, eco cotton, dry only and many more options contained in the simulator. By using a digital key tactile switch, we can choose the respective programs with the help of switch 4. The user has to long press the key 4 to select the program. Then it moves to the next stage after selecting the program. Then the CLCD displays the different water levels. The user can select particular water levels required by the washing programs. Even in the CLCD display the water levels like auto, low, medium, high and maximum. Similarly, the user can scroll down to select the water levels. By long pressing the switch 4, the user can select those water levels. After selecting these water levels, the CLCD displays press switch 5 to start and switch 6 to stop. If the user presses the switch 6 to start the program, then it returns again to the washing programs. If he presses the switch 5 to start the program, then it displays the user to about the selected program. The CLCD displays a particular program and time to watch the selected program in minutes and seconds. Then the machine starts to run. At the same time, motor, fan, rotor rotates, and it will be showing the remaining time to complete even if the program shows whether the clothes are washing or rinsing or spinning. CLCD displays 5 to start and 6 to pause. If the user press the switch 6 to pause and washing stops, even the time has to be stopped even the motor stops rotating. Again, if the user presses the switch 5, then the washing starts and the rotor begins to rotate. If the switch 1 is not pressed, then it indicates the washing machine door closed. If switch 1 is pressed, then it indicates the washing door is open. If the user presses the switch 1, then the buzzer turns on to indicate that the door is open at the time of washing. If the user opens the door by pressing a switch 1, then CLCD displays a message like door is open, please close it. When the washing is completed and when the time returns to 0, then the rotor stops and the buzzer turns on, indicating that the program is ended, so you can take off your clothes back. After finishing it, program completed, remove clothes, then at last it again comes back to the washing program display.
Hi, this is Srila Hari Krishna, and I am going to explain you how this washing machine is implemented in Picsimlab using Mplab. So where I have coded is in Mplab. So I have selected my board as PicGenius, my microcontroller as PIC16F877A. I have loaded my hex file here that says washing machine x production.hex. So this is the peripheral that where we can understand this working of washing machine. So I have a 16x4 LCD display here that says press key 5 to power on the washing machine. I have a cooler, buzzer, group of displays, switches, 3 switches here and a group of switches here in this row, and I have like keyboard, group of LEDs, and this is the microcontroller that says PIC16F877A that I have selected here. So firstly the screen says press key 5 to power on the washing machine. So now I'll press this key 5 to power on my washing machine. Now it says powering on washing machine and I can see washing programs. So this viewing this can indicate that washing machine is on right now. So in my washing program I have many options like daily, heavy, dedicates, whites, stain wash, eco cottons, woolens, bed sheets, rinse plus dry, dry only, wash only, and aquastore. So aquastore is my last option. So immediately if I come to aquastore and click on next, it gets to the starting like daily, heavy. I can watch, see, daily, heavy. So like if I press this switch 4 for once, it gets shifts to the next option. While I long press this option will get selected. Now let me select this daily as my washing program. So I'll just long press this key. Now daily is selected and it is asking me to select the water level to wash my dailies. So here are my water levels options like auto, low, medium, high and maximum. So I'll just click on auto. Like I have to long press this to select auto option. Now it says press switch 5 to start the operation, switch 6 to stop the operation. I'll press switch 5 to start the operation. Now it says program is washing dailies and the time for it is 42 seconds. It has started the operation to wash my dailies. Now if I in case just I wanted to pause this operation, I can press on this switch 6. So this shows 31. It has stopped at 31 seconds. Now I wanted to start it again. So I'll just click on switch 5 again. Now if I press on this switch 3, it says door is open, please close the door and the buzzer gets on as an indication. So if I just leave this, the washing program will start again automatically. Now it is at 20. Now rinse operation has started. We can also view the spin operation that is getting done in few seconds. So if I wanted to pause the operation, I have to press this switch, and if just in case door is open, it just shows like this. So after this 6 seconds of rinsing, spinning and washing, this fan will get off automatically, and here on the screen it shows program completed, remove cloth with a buzzer sound of indication. So this is how the washing machine will work, and here we have a reset option to start now I like off the washing machine. So it again says press key 5 to power on my washing machine. So if I have to wash things again, I should just click on the buttons, like I have to repeat the same process that I'm doing from starting. Long press and all. This is how a washing machine will work. Thank you.